Personal automated ethanol fermenter and distiller. We wanted to create an apparatus that individuals would use to create their own E85 fuel to be used in their automobiles. The apparatus would go through the fermentation and distillation of corn to create ethanol. But we also wanted the machine to operate automatically so that little human assistance is needed. To start the ethanol making process, a push button is pressed. Our machine's automatic capability is possible because of the microcontroller that is incorporated into the electrical system. All electric devices are controlled by the microcontroller based on its programmed code. When the button is pressed, the microcontroller is allowed to start the sequence of programmed code. Water from the black tank is pumped to the top stainless steel pot. The microcontroller turns on the electric ball valves and SureFlow pump to accomplish this step. Once the water sensors in the top pot are tripped, the microcontroller turns off the electric ball valves and SureFlow pump. The top stainless steel pot is now full of water. The water in the top pot is heated. The heating source used in our machine are two heating elements that are common in water heaters. The microcontroller turns on the heating elements and monitors the temperature using the thermocouple. The purpose of heating the water is to sterilize it and to make it possible to add the enzymes and yeast at their optimum temperatures. The heating elements heat the 25 gallons of water approximately 1 degree per minute. After about 2 hours, the water begins to boil and the correct water temperature is reached. The thermocouple tells the microcontroller that 212 degrees has been reached and the heating elements are then shut off. Next, the microcontroller turns on the solenoid valve that is located underneath the stainless steel pot for a programmed amount of time. The hot water drops into the fermentation pot where ground up corn is awaiting to be mixed with the water. The amount of time the water takes to drop into the bottom pot was calculated and then implemented into the controller's programmed code so that the solenoid valve is open and then closed according to a timer. After 5 minutes, all the water should be in the fermentation pot. Mixing the fermentation liquid and adding the enzymes and yeast are done manually. Once the 75 pounds of ground up corn and the 25 gallons of water is mixed together, the mixture appears thick. Also, during this time, a second thermocouple is monitoring the temperature of the mixture and that value is displayed on the computer screen. The purpose of enzymes is to create an environment where the yeast can multiply and thrive. The yeast then produces its alcohol byproduct much faster than natural fermentation. The first enzyme to be added is the alpha amylase enzyme. The optimum temperature for this enzyme is 194 to 203 degrees Fahrenheit. The purpose of this enzyme is to liquefy the corn-water mixture and to break up the glucose molecules into shorter chains of sugars. The enzyme immediately liquefies the mixture. Once the corn-water mixture is thoroughly agitated, the mixture turns completely into a liquid. Also during this time, the liquid is continually cooling down approximately 0.3 degrees Fahrenheit per minute. The glucoamylase enzyme is added at an optimum temperature of 136 to 144 degrees Fahrenheit. This enzyme takes the chains of sugars and breaks them down even further into simple sugars so that the yeast has readily available sugars to process. Finally, the ethanol yeast is added at a temperature less than 120 degrees Fahrenheit. Because the yeast is primarily used for making ethanol, it can withstand higher temperatures than normal baking yeast. The yeast consumes the sugars that were broke up by the enzymes and produces byproducts of CO2 and alcohol. A fermentation lock is used to keep contaminants out of the fermentation liquid. Now the yeast is allowed 2 to 3 days to produce the alcohol. Over time, the yeast will produce CO2 bubbles that will float to the top of the liquid. At this point, the liquid should not be agitated continuously because stirring up the yeast will cause the little microorganisms to consume faster than normal and, in the end, cause premature death. The fermentation liquid now needs to be pumped to the top stainless steel pot. Once the microcontroller times out 3 days, it will turn on the solenoid valves, electric ball valves, and the SureFlow pump for a programmed amount of time. In order to separate the distiller's grains from the fermentation liquid, the liquid must pass through a strainer located in the bottom pot and an inline strainer right before it goes through the pump. After 10 minutes, the microcontroller shuts off the pump and valves. Now the top stainless steel pot is filled with fermentation liquid. This is called a hydrometer. It is used to calculate the alcohol content of a liquid. The highest alcohol content after fermentation that we got was 8% alcohol. Next, the microcontroller turns on the heating elements. This is the start of fermentation. The boiling point of water is 212 degrees Fahrenheit and the boiling point of alcohol is 173 degrees Fahrenheit, so the first steam to rise is mostly alcohol. The steam is first funneled into the distilling column, which is this long 2-inch cylinder of copper. The distilling column is where the separation of alcohol and water takes place. Packed into the column are copper scrubbers that are normally used to clean pots and pans. When the steam comes in contact with the copper scrubbers, it recondenses. Since alcohol has a lower boiling point, it is the first to re-vaporize from the continued supply of hot steam, and the alcohol continues its way up the column while the liquid water drops back down into the pot. The alcohol steam goes through the rest of the copper tubes until it reaches the condenser. The condenser is located at the top of the copper parts. The condenser recondenses the alcohol steam and the alcohol drops down into a reservoir bowl. The microcontroller is continually monitoring the temperature of the fermentation liquid and keeping it within 175–185 degrees Fahrenheit. Simultaneously, the microcontroller is also running the SureFlow pump to supply the condenser with cool water. The pump runs for a few seconds and then shuts off for a few seconds. The water continues to recirculate back into the black tank. The condenser is made up of 1/4-inch malleable copper tubing coiled into a spring. As the alcohol steam comes in contact with the coil, the cold water running through the small tube recondenses the liquid. The liquid alcohol falls down into a reservoir bowl where a solenoid valve, controlled by the microcontroller, turns on periodically and the alcohol is then allowed to continue its way down into a container. If the solenoid valve is turned off, the alcohol will be redirected back into the distilling column where the liquid will have to be vaporized again. This recycling method results in a higher proof ethanol. So during this whole time, the microcontroller is controlling the fermentation temperature, pumping water to the condenser, and the solenoid valve that the alcohol passes through. As the machine puts out more and more ethanol, the alcohol content decreases. The first bit of ethanol made will have the highest proof. After a programmed amount of time, or if the fermentation liquid level drops down below the heating elements, the microcontroller shuts all electric devices off and the process is over. Using the hydrometer again, we can calculate the final alcohol content after distillation. This bit of ethanol appears to be 75% alcohol. The highest alcohol content that we achieved was 80% alcohol. This is a little experiment that we did by burning the recently made ethanol and gasoline. The gasoline has a very large, bright light when burned, and also creates soot. The ethanol has a smaller, cool, blue flame that is very clean. After the fuels have been burned, the gasoline leaves behind a black residue, while the ethanol doesn't. Devin and I have learned a lot about making ethanol and what it takes for an engine